Hello all. We'll wait for a few more minutes and we'll start the session.
Yeah, hello, am I audible?
Yes, ma'am, you are audible.
Yeah, okay, thank you. So this is Solve with Instructor session for week 11. Yeah, I will share my screen. So you are able to see my screen, no?
Yes, ma'am.
Yeah, okay. Let's proceed. Please try to fill the code there. So I have not made it as peer deck session, so we can
Okay.
discuss this question.
Ma'am, can we, for this one? Uh,
Yeah, for this one, you just
okay.
think by
Okay.
yourself and
Sure.
later we can discuss. Okay.
Sure, ma'am. Sure.
Yeah. So let me know once this is done. Okay.
Done now.
Yeah. Just will wait for 1 or 2 more minutes.
Sure.
For this also.
What's the code if I can ask? I just joined actually.
You are done, no? We'll discuss what is the code, like what should be the code.
No,
Okay.
no, ma'am, not this code. I mean the peer deck code I'm asking about.
No, this is not a peer deck session, just a presentation only I'm sharing. This is not in the peer deck. Okay.
Oh, okay, ma'am. Okay, ma'am. Thank you.
Yeah. So everyone done? Should I wait for a few more time or shall we proceed? The few people are joining now itself. So actually, given a list of integers sorted in ascending order, write a recursive procedure that returns a list sorted in descending order. So we are given a list of integers sorted in ascending order. Let us take an example here, a list that contains number 1, 2, 3, 4, 5. This is ascending order, small to big. Write a recursive procedure that returns a list sorted in descending order. We want a list sorted to be sorted. Return a list that should be sorted in descending order. So what we can do is, so we want, now ascending order means small to big. Descending order means from largest number to smallest number. So yeah, if we bring the
Like,
last element.
can we write return last of L plus plus this init of L?
Yeah, that's what. Yeah, that is correct. Yeah. So actually, I'm explaining that logic. So what we can do here in the ascending order, we can see the elements are arranged in this manner. In order to make it as descending order, if we move the last element to first, and the remaining list will be 1, 2, 3, 4. And the second time, if we move the last element of the remaining list to the second position, again we will get, like, if we do in this manner, then yeah, if we do this like first 5, 4, 3, 2, 1, if we move, then we will get a list that is sorted in descending order. So what we are moving the last element, we are just last element to first, and then we are again calling the procedure descending of remaining of the list. So that's what. So for this, so yeah, if the list contains only one element, we can return that list as it is.
Yes.
Right?
Yes, ma'am.
Yeah. So yeah. So if the return contain one or no elements, then we can return the list as it is. If not, what we can do is we can we can first bring the last element. We can return a list that has the last element, and then we can call this same procedure on the remaining list. That's what. So how the procedure is executing, I will tell. So first we are calling descending order on this list 1, 2, 3, 4, 5, this procedure. So what happens for the first, in the first iteration, it will, what will be our list in the first iteration? It will be 5 plus plus descending of 1, 2, 3, 4. We're calling the procedure descending on the remaining list. Okay. In the second iteration, it will be 4 plus plus descending order of the remaining list, descending procedure of the remaining list. In the third iteration, it will be 3 plus plus descending order of 1, 2, 3, 1, 2. In the last iteration, it will be, in the next iteration, it will be this one, 5, 4, 3, 2, this plus descending order of 1. So finally, the element of what will be the output here for descending of 1? The output will be 1.
Descending of 1 would return the list.
It will return the list. That will be 1. So what will be our procedure will do? It will compute the return value, final return value. It is like 1, like 2 plus plus 1 will happen. That will be 2, 1. and then it will
Ma'am,
be
it,
to 1.
ma'am, it would just walk the path that it has walked already, but in a
Yeah,
backward way.
backward.
Yeah, in a backward way, but it won't go 5, 4, 3, 2, 1. 5 won't be appended first. So 1,
Yeah.
after getting 1, 2 will be appended to the list 1. And after getting 1 to 1, 3 will like 3 will be appended, like it will be appended to the front because we are adding it to the front row. So that's how this procedure works. So go through this problem statement once. So should I move to the other slide where I will show some code?
Just a second.
And such questions will be given in the end term, ma'am. Where we
No.
have to write the
Yeah,
pseudo code.
you have to write the fill the missing code. Yeah.
Okay.
Like, ma'am, we won't have the options, ma'am. We need to fill it, ma'am.
Yeah, this kind of questions you won't get. Options will be given for you. Okay.
Okay, ma'am.
Yeah.
What is the problem statement, ma'am? Here didn't follow. What
Ma'am,
we have
is
to
it
write.
return? Is it return numeric rest of L minus 1?
Yeah, that's correct. Yeah. So you have to number of moves, if it is equal to 0, then you have to return true. Like, so here you can see the problem statement. The boat can either move one step left or one step right at a time. The sequence of moves of the boat is recorded in a list called moves. For example, consider the following. Okay, write the procedure that accepts a list of moves and returns true if the boat is at same place where it started and false otherwise. So we have to return true if the boat has made if it is at the same place after moving all these turns. If it is at the same place, then we have to return true. But if it has moved somewhere, like from the starting place, if it has moved away, then we have to return false. That's what our procedure should do. So when the number of lefts and number of rights are equal, then it will be at the starting position of the boat.
Yes.
Yeah, that's what you have to do in this code. You have to find if the number of lefts is equal to number of rights, then you should return 0. You should return true. That means the moves equal to 0 and you should return true at that time. So is it done? Should I wait for a few more minutes?
No, ma'am, it's done, ma'am. You can discuss.
Yeah, sure. So the same, let us imagine a list of moves that has left, right, right, left. So if the board takes a step, take first left one step and then right, so it will be at the initial position only, after left and right. Again, if it takes one step right towards right and one step towards left, it will be at starting position only. So at the time, number of moves will be equal to 0 and the board will be at starting position and the procedure should return true in this case if the board is at starting position. So what we can do is whenever the board takes left as a step, then we can count it as -1. Whenever it is taking right, we can say it as +1 step. And same thing, if it is right, +1, if it is left, it is -1. So finally, we can sum up all these things and we can get the number of moves. So finally, sum is 0. So let us write the procedure. So in order to do that, what we are doing here, first we are taking first step, first of L, right? First of L, we are checking if the numeric of L, that is the number of moves. If the length of our list is 0, then our number of moves is 0, right?
Yes.
If the first of L equal to left, if the list has some elements in it, then what we are doing is we are checking the first element, and after checking the first element, like if it is left or right, we will check. If it is left, then what we will do is like we should count it as -1, and then we can say plus numeric of rest of L. So we can do the same thing for the remaining elements of our list. If it is not left, then if it should be right. In that case, we have to count it as +1 more. So what we will do, we can write it as 1 plus numeric of rest of L also we can write. So we will add 1 first, and then for the remaining element, we will call the procedure. For the remaining elements in the list, we can again call this procedure numeric of L. That will finally give the number of moves which are present in the.
It's also a recursive
Yes,
procedure.
it is
Numeric
also
is
a
a recursive procedure.
Yeah, why it is recursion? Because we are in each iteration, what we are doing, we are not iterating actually. We are calling this function over the list again and again. What is the thing that is changing? Only the data to the numeric function. So inside the function, inside the return statement, what we can do, we are calling the numeric procedure again. Right? We are calling the procedure numeric recursively until our list length has become 0. So that's why it is recursion, because we are recursively calling the procedure numeric just by decreasing the data every time. L is changing now.
In the first step, what is the content of numeric L, ma'am? In the initial step condition.
So okay, this has to be stopped at any point of time, right? This iteration return numeric of rest of L, that should be stopped at any time. When it should be stopped? When our length of list is 0. When there is
When we have reached on base.
Hello.
Some disturbance.
Yeah, it's not audible now clearly what he is saying.
No, ma'am.
Yes.
Okay, so just we'll take whatever the list we are passing, we'll execute the list and we'll see. So numeric of left, right, right, left, this list we are passing to the procedure numeric. So what this procedure is doing, so what is our first move? Previously it is left, no? So for the left, what we are doing, numeric of right, this whatever the remaining rest of list that we are passing after removing the first element, the rest of list, and as it is a left, we are adding -1 here. Okay, in the second, in the next time, what we are saying, we are calling the procedure numeric again by passing the list this list, right, left, no. So at that time our move is like right, so it will execute, it will go to this call, numeric of rest of L plus 1, that will happen. So what is our numeric of rest of L? That are the remaining elements after the first element is after discarding the first element, that is right and left. So numeric of right and left and -1 plus 1, that will be there. Okay, that is like from the previous thing. And then in the next iteration, what will happen? It is like, what is our element in the next iteration? It is right again. So it will be going to this part. It will be going to this part and it will just execute the return of rest of L, numeric of rest of L plus 1. So what is rest of L? Numeric of left, and the plus 1 also will happen. Whatever that are there previously, that also will be added up. The same thing will happen, and finally your list is empty, so it will return 0. So after returning 0, the procedure, what it will do, it will compute 0 minus 1 is -1 and -1 plus 1 is 0. Again this addition will happen, and finally our sum will be 0. So that's how this procedure is actually returning. These procedures are returning some values, no, that will be computed, that will be appended. Finally, number of moves will be 0. So if the number of moves is 0, then it is returning true. If not, it is returning false. So this is based on DFS. So everyone knows, right, how DFS work?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Done, ma'am.
Yeah, yes, please. I am moving to the next. So just traversing, how traversing happens in case, okay. So let us see how the traversing happens in this case. So first, we'll start with the node 0, starting from node 0, no? So node 0 is connected to two nodes, 1 and 2. So here both, in the case of, see here you can see in case
4
of
also, no,
time.
ma'am. 4, 5 also is connected.
Yeah. So it is connected to 1, 4, 1, 2, 4, 5 for every node. So all the nodes are connected, like 0 is connected to all the nodes. So which node to choose? The smallest
1.
node we have to choose. So what is the smallest node? That is 1. So 1 will be the next point of traversal. So 1 is connected to 0, 3. As 0 is already traversed, so what is the next other visited non-visited node, which is 3.
3.
Yeah, no tie here. Yeah, 3. And coming to 3 is connected to 4, 5 and 1. As 1 is already visited, we won't visit 1 again. And for coming to 4 and 5, like 3 is visited to both 4 and 5. 3 is connected to both 4 and 5, but which is the smallest node? 4 is the smallest
4.
node. Yeah. So what will be the next point? That is 4. So now coming to 4 is connected to 0 and 3. And 0 and yeah, 4 is connected to 0 and 3. So 4 is connected to both like 0 and 3, and both are visited. So what we will do? We will go back to 3 again and see which are the non-visited rows, non-visited nodes. So 5 is a non-visited. So in the case of now 5 has happened, you know?
Yes, ma'am.
Yes, no. Yes, no.
Yeah. Now coming to 5, 0 and 6 are connected. So 0 is already visited. It will go back to
6.
6. It will go to 6. So yeah, coming to 6, 6 is connected to 5 and 5 is already visited. What we will do, we will come back to 5 again because no other nodes are left, no? So we will come back to 5 again. So coming to 5, 5 is already like connected to 0, 6 and 3. All of them are visited. So we will go back to 4 again. What is the, we will do backtracking. 4, 4, because we will do backtracking, no?
No, ma'am, we will go back to 3, right? For 4, we went back to 3. Then from
Yeah, for
3, we
4
went,
we get, so how we got to 4? We got to 4 from 3. So how we got to 5? From 4. So we'll go back to 4. Okay.
ma'am, we went from 3 to 5, right?
4
We
is not
went,
there, ma'am. 4 by mistake we have adding in the list. 4 was left off, no, ma'am. Since 0 and 3 are connected to 4, we left 4 and we came to 5.
No. It should
But-
traverse
but-
to like that 0 to 1,
Yeah.
1 to 3, 3 to 4, and 4 we
And
go
then
back
coming
to
back
3.
4 to 3.
okay.
Exactly.
Yeah. So like from where we have visited, we should go back. From how did we get to 5?
3.
We get to 5 from 3. So we'll go back to 3. From 3, like where we have, from where we got to 3, like from 1.
1.
So 1. So 1 from where we got to 1? From 0. Yeah. From 0, yeah, we can see like 0 is connected to both 1 and 2. 1 is already visited. What is the remaining element?
2.
Node, that is 2.
2.
So 2 will be visited finally. So this is how tracking happens here. So after 6, it will 6 is connect like no more left. It is not connected to anywhere. So we'll go back to 5, and 5 we will see whether like no more non-visited nodes. So we'll go back to 3, and from 3 we'll go back to 1, and from 1 we'll go to 0, and 0 we will reach to 2. That's how the traversal will happen.
What happens at 3, ma'am, at node 3 in the big?
So what happens at node 3? So node 3 is connected to both 5, 1 and 4. All of them are visited. All of them are visited, right? Because we have formulated our list of visited nodes here. So yeah, 4, 1 and 5, all of them are visited. But how we got this 3 node? From 1 only, right? From 1 only we got to 3 node. So we'll go back to the first node again. First node, and we will check what are the non-visited nodes. So from 1 there is nothing like non-visited. 0, 3 are already visited. So how we got to 1? From 0th node we got to 1. So yeah, we'll go trace back to 0 again, and from 0 we can see which are the non-visited rows. Only 2 is non-visited nodes, so that will be visited next. Okay. So just what we will do here, we'll traverse the graph in a depth first manner, starting from the node 0. Like every time, this need not be a case. We can start from node 4 also. Okay. And then we can start from that node, and we can traverse in the depth first manner. If some tie occurs, we will choose a smaller node. Okay, if we have reached something like this, no nodes are to be like something like 6 here. Here nothing more is left, right? All 6 is not connected to anyone. So we can just track back to the to the visited node again, like 5. We will backtrack. So let us see what will our output be if we start traversing from 4. If the 4 is the first visited node, then what will be our output? Can anyone tell?
From 4, we will go to 0.
Yeah.
So we have 4 is connected to 0 and 3. So, but we'll go to the smaller number first. So we go to 0. So 0 is connected to 2, 5, 4, 1. 4 is already visited. So we go to 1. Then from 1 is connected to 0 and 3. Since 0 is already visited, we go to 3. 3 is connected to 5 and 4. 4 is already visited, so we go to 5. 5 is connected to 0 and 6. Since 0 is already visited, we go to 6. 6, we don't have any thing to visit, so we go back to 5. All the nodes from 5 are also visited, we go back to 3. All the nodes from 3 are already visited, we go back to 1. We go back to 0, and from 0 we go back to 2.
Yeah, that is correct. So others also please think on this and just let me know if you have any doubts. I will give 1 or 2 more minutes and just will think like how traversal will happen if it is from another different node from 4 or for 3 or any node you can choose, and just try to understand how this happen traversal.
Ma'am, I just have a normal question. I mean, apart from the traversing thing, from a maths perspective and from CT perspective. So, may I?
Yeah, actually, yeah, please tell.
So, ma'am, in the last term, in maths 1, the graph theory, it was totally mathematics, code or hard mathematics. So there actually the questions were like this, the instructions were given how to traverse the DFS. Because like here, we are implementing the condition that we would choose the smallest node as the index. So 0 to 1 would go, we would go, not 0 to 2. But in maths 1, it was totally different. All the possible traversing routes were there, and such questions were MSQ. So my question is, in CT, can we expect such kind of questions in
No,
exams?
no,
Or
no.
it is I mean, it is totally implemented, like we can go from 0 to 2. I mean, it's an incremental order we would search in DFS.
So no, whatever I have mentioned, if there is some time, we'll visit the smallest node. That is the only one condition is in this graph in CT coming to CT course.
Okay. So
There
we don't
won't
have
it
the
won't be
overall
MSQ.
thing.
Yeah, it will be MCQ only every time because
Okay.
there is only one possible thing.
Also,
Okay, ma'am. Okay, ma'am. Got it.
one small request.
Yeah.
Once we're done discussing how to traverse this graph through DFS, can we also discuss how to traverse this graph through BFS?
That is not there in CT, no?
There were questions, ma'am, related to that in the
Yes, ma'am. There
assignments.
was one question. One question, I
Yes.
think.
It wasn't in
Just one question, ma'am.
lectures, but it was in questions, ma'am.
In activity question.
Yes, ma'am.
Yes, ma'am. And in some lecture also, he described a little about that.
Okay. So what according to the BFS, I actually according to BFS, how the traversal happens, what is the condition? Did they mention something?
No, ma'am, nothing, ma'am. Nothing of
Go
this.
by
No,
level
ma'am.
by level.
Ma'am,
They
ma'am, for BFS condition is whenever you are selecting a node, you have to check all the neighbors first, and once it's done, that means let's take 0. So all the traversing would happen for 0. So let's say 0 to 1, then 0 to 4, then 0 to 1, 0 to 2, 0 to 4, 0 to 5, according to the logic that we are using over here. So 0 is done, then we would choose any of the neighbors of it, and we will see if we can go further ahead. So BFS, I mean, from maths logic, it goes like that.
No, coming to in the CT lecture or something.
Ma'am, it's same way, like he told. Like from 0, all the neighbors of 0 will be completed. Then we'll go to the next neighbor. Then 1, let's say that 1 is there. Then all the neighbors of 1 will be completed. Then we'll move on to other neighbors of the thing, and that's how we go in CT as well.
So, but
Is there any
Ma'am,
similar lecture in week 12 CT? I don't see any.
I think
week
it
12
was
it
around
is
the last
revision.
of 11.5 or 6 something. It was
it
11.5
was
or 6.
quite. It's activity 11.6. The thing that I was asking you, ma'am, because in the 11.6 there was a particular question number 5. Question number 5, or was it? Let me just take a look at it. Question number 3, ma'am. And in that question, they explain, they give you the sequence. Question number 2, they give you the sequence through which you will visit those nodes in through BFS. But in that case, there was a small thing. They missed a node and jumped to the next node. So that is something I couldn't understand. So if you can take a look at that question after this one.
Yeah, sure. Yeah. So the same thing, 0, 1, 3. And from 3 we'll go to 4. From 4, nothing, like everything is visited. So we'll go back to 3. And from 3 we'll go to 5. And from 5 we'll visit 6. As 6, nothing is left. So we'll go to 5. And then from 5, nothing is left. So we'll go back to 3. From 3, nothing is left. We'll go back to 1, 1. From 0, 2, we'll get 2.
Ma'am, there is little
Yeah.
bit contradiction, no, ma'am. When we can go from 3 to 4, why didn't we go from 0 to 4, ma'am, initially? When there is a choice between, at the vertex 3, there is a choice between 4 and 5. We are going
No,
to
no,
4.
I'm not getting you. Which one? About which node you are telling?
At the vertex 3, there are 2 choices to move, no, ma'am, 4 and 5.
Yeah.
Similarly, at 0 also there is a choice from 1, 2, and 4.
So we are taking the smallest node, no? We'll consider the small.
When we can still go forward, and we left 4 and 2 and we moved forward to 3. From 1. From 0 to 1, we have moved forward to 3, no, ma'am.
From 0. So what we are doing is we are starting from 0. 0 is connected to 2, 4, 5, and 1. So what is the smallest node among them? That is 1. So we have chosen 1. So from 1, 1 is connected to 3.
We are moving forward in that direction to 3, from 1 to 3.
Yeah, 3. So now
We have left
visited
all
3.
the rest of the 3 nodes we are leaving, no, ma'am. 4,
Yes,
5, and 2
yeah.
we are left, and we have come ahead.
Yeah,
to 3.
we are 3. And from 3 we will do the same thing. What is the smallest node, connected node? That is 4 only, no, smallest one. So 4, yeah, from 4, yeah, we can see 4 is connected to 0 and 3. But 0 and 3 are already visited. So what we will do, we will go back to 3 again, because we have came to 4 from the third vertex only. So we'll go to 3. From 3 you can see 4 and 5. But 4 we have already visited. So we'll go to 5 again. That's how the traversal will happen.
Yes, ma'am. Whenever we encounter a next shortest, smaller, we have to go there.
Then that will be our next point of that. Yeah.
But in maths, that's what.
Yeah, don't look at max now. Yeah, that is confusing. Yeah, just.
Okay, right.
So you have to write a recursive procedure to traverse this graph in a depth first manner, starting from any given node I. So just one recursive procedure you have to come up with. So because why it is recursive? It is recursive because for 0, what we are doing, we are choosing the smallest one. For 1 also, we are choosing the smallest one. That thing, the smallest thing we are visiting next, that we are doing for every node. So that's why it is recursive. The same thing we are doing. So you just, this is the thing. You just try to fill in the code here.
So ma'am, according to this code, we are actually returning 2 things. So we need to keep track of 2 things. First is sequence, second is the parents thing, isn't it? For this particular question.
Yes, yeah.
All right.
Now, will it be P comma S equal to DFS APS J?
Yes.
Is that correct, ma'am?
Yeah, we'll see. Yeah.
Ma'am, actually, I had a little doubt in some other exercise like 11.5 question number 3. Would you be able to do that, Abhi?
Yeah, after this question, I will do that.
Okay, ma'am. Thank you.
Yeah, is it done?
Yes, ma'am.
Yeah, let us wait for a few more minutes. Yeah, let us see. So anyone of you, would you like to discuss?
Ma'am, since P is an empty dictionary, and we are marking the first node that we are starting from as key, and we are assigning a value -1 to it. And S is an empty dictionary, empty list here, and P is we're calling procedure DFS for P, and with parameters A, B, S, I. And we go to procedure DFS. S, we add the current node to S,
the empty list. It will be a list with element the current node. So for each j in columns of A, so for this, I think the A is a matrix. Yeah. So A is a matrix. So for node I, say we start from 0. So for 0, we will look for each column and we will check that if it has it is connected to those nodes. So if it is connected to those nodes, the value for 0 to that particular column would be 1. And if it is not visited, that means that if it is not present in the dictionary P, then we will execute the if block. Then we will assign a new value for that column in the dictionary P, and the value would be the parent of that node. So according to me, ma'am, it should be P comma S equal to DFS APS J. That means we call the DFS for the new node, the child node for that. Ma'am.
Yeah, yes, yeah,
Yeah.
thank you. So do you have any other doubts, any others? So actually we have what we have to do. So there is one dictionary which keeps track of visited nodes, that is P. So how we are keeping track? So by making those whatever the nodes which are visited them as keys, and from where we are visiting that node, that will be marked as its value. So starting from 0, actually we are starting from that initial node. No, 0 is our initial node. So 0 will be key here. P of I equal to -1 we are making, no, and it is mapped to -1 because we are starting from that point only. And S is a list that keeps the track of visited nodes. That will be the list, that is like that will be the list whatever the path
Ma'am,
that will store the path.
why we're taking -1 here?
Yeah, because that is our starting node. We are not visiting 0 from any other anywhere. No, 0 is our starting node. So that's why we are making it as -1. If we make it some value, like some value which is already there here in the graph, then it won't make sense. So that is the other value here is like -1. No, that we can make, which
Okay,
is
ma'am.
not, yeah. Now we are calling the DFS procedure by passing A which is a matrix, and P. This is the matrix for this graph. So if how can we know whether 0 and 1 are connected? If there is an edge from 0 and 1, that means the value, if the A of 0 1, if that particular matrix value is 1, that particular element value is 1, that means both 0 and 1 are connected. So by checking that the element value, we will know whether that particular nodes are connected or not. So that is our A matrix, which stores the information of this graph, and B is a dictionary which keeps track of visited nodes, and S is our path of traversal, and I is our starting node. So we are passing all these things to our procedure DFS. So what is our first path, first thing, that is our I, know. So I should be appended to our path. So S will be storing that information. So the first element in our list will be 0. So and then we are iterating over the columns of J. That means we are iterating from I. We should check from this 0, that is 0 is nothing but our I. We should check like 0 is connected to what all elements. So 0 is connected to 1, 2, 4, 5. How we will get that information? We should iterate over that matrix. For each j in columns of I, of A, we will check if A of ij equal to 1. So as we are iterating over the columns of A, columns will be starting from the lowest value, like 0, 1, 2, 3, 4. No, so it will check whatever we are doing. It will be checking the smallest one only first. So if a of ij equal to 1, and if it is not key in our this dictionary, then that should be again like p of ij. Then we should mark that node as visited, and like p of j equal to I we should do, that is we are visiting from, like here we will start from 1 only. No, like for each chain columns of A, that means it will be 0, 1, 2, 3, 4, 5, 6. So yeah, first starting from 0, we will see if 0, 0 is equal to 1. So 0, 0 is not connected, it will be 0. What will be the next element? If 0 and 1, if A of 0, 1 equal to 1, yeah, A of 0, 1 is 1. And we will check if not is key of p comma j, whether that key is there, j is as a key or not, we will check. So this dictionary has only one key value pair, that is 0, and that is mapped to -1. It doesn't have 1 as key. So this condition is satisfied. And what we will do, we will make p of j equal to I. What is p of j? P of j equal to I means we are adding a key, that is j. What is our j? That is 1 equal to 0. So 1 will be mapped to 0. That will happen here. Our dictionary will be updated. And what we will say, p of s equal to p comma s equal to, again this procedure is actually returning p comma s. No, that value we are storing here, p comma s equal to dfs of a p s j. So that will happen. So the updated dictionary will be given, the updated list will be given to our DFS procedure, and the matrix and this j value. So at that now j value will be passed as 1. So that's what we are doing. No, so after visiting 0, we will visit 1. So we will pass that node for DFS procedure. So from 1, it will again will check the condition for each j in columns of A. It will check whether 0, it is connected to 0, 2 and 3. Like 0 is already it is connected, but it is already key in our dictionary, so this condition will not be satisfied, so it won't visit 0 again. Coming to 2, 2 is not connected. Coming to 3, 3 is connected and it is also not visited, so it will visit again. It will mark, it will update our dictionary. P of j equal to I will happen, and again we will pass the new dictionary, and whatever, whenever we are passing some element, some j, that will be appended. No, s equal to s plus I will happen. So now we'll pass here 3, that 3 will be appended to our list. So every time the procedure is same, like it is doing the same thing. DFS on what? On the visited node, whatever we are visiting, that node it is doing DFS, that thing. It is recursively calling the DFS procedure. Okay, is it clear or not? If you have some doubt, please ask.
Ma'am, a small doubt. Usually, when we call a procedure, we are calling a procedure and we are assigning whatever the value that procedure returns to a variable. So when we enter this if block and we say p comma s equal to dfs apsj. So I know that dfs apsj is calling the procedure dfs again with just a small change in the parameter, that is j, that is the daughter node. But what is that p comma s would mean? That
See,
usually there is one
actually,
variable.
yeah, p comma s, actually this procedure, when this procedure returns, after iterating through each and every element, no, finally only it will return. Yeah, so after finishing this j thing only, this iteration of your matrix, and only it will return. So actually p comma s won't be updated every time. It will happen recursively. No, recursively, no, right? I will show whether this is there or not. So first you can see a DFS of 1, 0 you are calling, and then yeah,
dfs for 2 when we are calling.
okay, from 2 we are starting. If it is 2, then from 2 we will start, and then 2 will be appended to our list first. After 2, what is the next thing? 0. 0 will be appended. So here p comma s won't be updated every time. Finally only it will be updated. Okay, let me see that step is there or not here.
Ma'am,
So from
that is what my doubt is. So when we
okay.
write p comma s, what do we mean? Usually what happens is we say for p equal to DFS APSJI. We know that whatever the value return DFS returns, it will be assigned to the p
Yes, p comma
initially.
s. P
But here
because
we say s equal to. So are we returning whatever the value DFS returns to? Are we assigning that value to s or p comma s or p?
so actually DFS of this returning two values. One is p and other is s. Two values actually it is returning. So the first value whatever that is procedure is returning, that will be assigned to p, and the second value whatever that is returning, that will be assigned to s. So here p comma
Okay.
s are dictionary. P is dictionary and s is list. Our variables, whatever variables we here we are mentioned in the procedure, according to this p is dictionary and s is list. So p will be assigned to dictionary again and s will be assigned to a list. Okay.
How can the dictionary contents be added to the list? S, S is a list and DFS is.
So DFS is returning p and s, both values it is returning. So p is nothing but you can see here p is a dictionary and s is a list. So whatever the values the procedure is returning, here DFS will be returning p and s, both values. The first one is dictionary and the other one is list, that will be assigned to p and s only. That will be updated. So finally our p and s will be updated. Okay, like if we call here p will be okay. Okay, you are telling, okay, yeah, there is some mistake here. It should be p comma s here also.
Yes.
Ma'am, this is something that's common in the uh, in the other pseudocodes as well.
In
Oh,
the
I
dictionary of
It's a
P,
syntax error actually. It's a syntax error over
Yeah.
there.
yeah, it
the
should be p
dictionary
comma
P.
s here. Here it should be p comma s.
That is what I was asking you, ma'am. That
Okay,
when we
okay. Yeah, p comma s it should be. It is returning two values, no? The two values should be stored. Then it should maintain two variables for that. Yeah, p comma s.
And ma'am, another thing is the function call should have the same syntax. I mean, once you are calling some way, the next time you cannot call the same procedure or same function in a different way until and unless
Yes.
it's a recursive thing. So once in the code it's p comma s, so the main call should be also p comma s. So it's a syntax error. Yeah.
Sorry, main call also should be p comma s.
yeah, in
What
the starting when
what
we
I'm trying to
call
say,
it.
the main call is p equals DFS the entire thing just after I mean the line 4.
Hmm. Yeah, yes.
So if it has to be a recursive call, it
Hmm.
should be called like this every time. But we are actually dealing with two return values.
No,
So the
no.
main call should be p comma s as well, because we
The
are dealing
fourth
with two
line should be
different
DFS
things.
P comma S only should be there, not four variables
So
inside the
p
DFS.
comma s, yeah,
So it should be p comma s equal to DFS
p
of
comma
a
s.
yeah,
Yes,
yeah,
that
yeah, that
thing.
should be there. Yeah, because here the procedure is returning two values that should be stored in every call. Like that should be stored, no? So that should be p comma s, and here also we are storing here. Yeah, that is mistake. The same thing we are doing here. Okay, do you have any doubts regarding this code, whatever that is happening here? Any specific doubt?
Ma'am, if we store P comma S at the beginning, then how will it show how to store? Because uh, at the beginning, S is equals to empty list and P is equals to a dictionary, right?
So it will be
So,
updated to new values, whatever DFS
so we
procedure is
can
returning.
call two variables at the same time by putting a comma. But for initialization, we have to put it differently, right?
Yeah, yes.
So it's not an error.
So it's, see why this is we are mentioning it as error.
P
Here
comma s is not initialization, it's a function call, so it's totally fine. So P comma s is not initialization, it's function call, so it's an error over there actually.
Yeah.
So what is the
Like
procedure
how,
DFS?
like, no ma'am, you continue. That's kind of out of context actually. I'm sorry.
So you can see what the procedure DFS is returning. It is returning P comma S. What is P? P is actually whatever thing we are passing. That is our dictionary. And what it says S is a list. So this procedure DFS is returning two values. So while storing also, we must be able to store. We must store those two values. A single variable. How a single variable can store the two values? That is not possible. No. That's why we needed two variables to store the values which are written by this procedure DFS. So there should be some two variables here. It can be a comma b or anything. So but here the whatever this procedure is returning p comma s, no, p is a dictionary and s is a list. If you say a comma b equal to dfs of this thing, then a will be stored in p, like p will be stored in a and s will be stored in b. So at that time a will be a dictionary and b will be a list. Okay, so there must be two variables here in order to store the whatever the values the procedure is returning.
Okay, ma'am, I got this. I got
Yeah.
it.
Yeah. So
Ma'am,
yeah.
just a conceptual thing that I want to ask. I mean, whenever we are traversing from a particular node, we are checking that all the outward nodes are there. No incoming node. I mean, no incoming edges to that node, right? So what if we try to traverse everything? I mean, the connected graph
So
from, let's say, 4.
this is
We start
not
from 4.
directed go. This is not a directed graph. This is undirected graph. You can see here.
No, 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 it's totally fine. But whenever we are actually dealing with such things, so in such case, we have to think that I mean, initially we would think that 4 has no incoming edges or like any parent. Like we would treat 4 as a parent in such case. That's
Mm.
what I'm trying to ask actually.
See what we are doing here. So you are telling 4 will be parent. Yeah, but 4 will be parent. 4 will has two child 0 and 3, but 0 and 3 are already visited, right?
No, 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 ma'am. No, I mean, not this case. I mean, let's say we are traversing, I mean, we are starting from 4. In that case, we would just
Go to
treat 4
3.
as the parent of 0 and 3, right?
Yes, yeah,
In that case, so
yeah.
that was exactly my question. So we don't need to change any code in such a way.
No.
Will
We
we
can start from anywhere.
actually,
That's my question.
So
will we,
even if
ma'am,
yeah, yeah, yeah.
will we actually consider 4 the parent for 0 and 3 in that case?
Yes.
Or we will, ma'am, we will only consider 4 the parent of 0, right? Because if 4 is the parent of 0, 0 would be the parent of 1, and 1 would be the parent for 3. So if 1 would be the parent for 3,
See
then 4
what
cannot be the
happens
parent.
here is like 4 is parent and it has 0 and 3, right? So but we will visit 0 only because 0 is smallest among,
Yeah,
like, yeah, 0 is smallest among 0 and 3. After 0, that will be 0 will be parent, and 1 and 2 it is connected to 1 2 4 5. Among them 1 is smallest. That's all. The
yeah,
same thing this procedure is also doing here. So we will mark first 4, and then for each j in columns of a, that means we will start iterating from 0. So 0 and 4 is connected and it is not a key. 0 is not a key, so 0 will be added as a key and it will be mapped to I is like 4. So that's how the same thing will happen. Okay, by smallest, you are getting every time smallest node only first. You are checking against the smallest node only first. Because of this, for j in columns of a, we are iterating from like 0 to the other values, no? That's why, yeah, we will always consider the smallest node from whatever the nodes we have. Like I will be some node, but we will be considering the smallest node only every time. That's why that is not a issue. Yeah, for our case, like, yeah.
Each node
Also,
will be a key in the dictionary of P. The
Sorry.
dictionary key will have the nodes as the keys.
Yes, visited nodes as the keys.
And the edges are the connect.
So it will have parent as its value. So now if we consider this for 1, what will be the parent? 0 will be the parent. So 1 will be key and 0 will be, it will be mapped to
value.
0 will be value. And for 3, what will be 3 will be key and it will be, the value will be 1. So actually, yeah, the visited node will be key and from the parent, its parent will be its value.
In the second line, ma'am, the P dictionary is written, ma'am, in the second line here. P, the dictionary, first node 2 is having -1 in the second line top.
Okay.
And 0 is having 2 now.
Yes, because now 2 is like it is our starting node. So it is like we are starting from here, we are starting our traversal from here. So the 2 is marked to -1, and from 2 we are visiting 0, and 0, for 0 what is parent? 2 is its parent, right? How we are getting to 0? From 2 only, right? So that's why 0 is marked to 2. From 0, yeah, we are going to 1. So 1 will be mapped to 0, because how we are reaching to 1? From 0 only. So 1 will be key and 0 will be its value. Okay.
Yes. From similarly for 3, we are coming.
Yeah, for 3,
from 1.
yeah, from 1. So 3 will be mapped to 1. Okay.
Yes.
Yeah.
So finally, what will be the P? How will the dictionary be?
Okay. P dictionary will be, I will show if it is there or not. So P dictionary is this. 2 will be mapped to -1, 0 is 2, 1 is 0, and from 3 is like 1, and from 3 we are going to 4. No, from 4, like for 4 it will be mapped to 3, and 4 we will backtrack to 3 again. 3 is already visited, it is already key, so you won't store that information. But yeah, you will get to 5. From 5, like how we are getting to 5? From 3. So 3 will be there, 5 will be mapped to 3, and from 5 you will be visiting 6. So 6, from 6 nothing left. No, all your graph is traversed, right?
Yes, ma'am. The first line, ma'am, here 2 is equal to -1. It should be always -1. We have to take it, or we can take any value for it.
Yeah,
2,
you can take any value, but it should not be there in your graph initials for starting. 2 should be mapped to some value which should not be there in your matrix. Like it
can be
can be
-10
something,
also.
yeah, it can be any value also, just because we are keeping track of the parent nodes, that is starting node. Yeah, it will be better to keep -1, because that won't be confusing, no, because nodes cannot be negative, right? We won't start with 0 1 in our matrix. Also it will be 0 1 2 3 4 only, right? It won't be -1 starting values.
Yes.
Okay, that's all I think. Yeah, we can discuss the doubts.
Ma'am, how can we transfer to this graph using BFS?
Yeah, just I have to check that. Actually, I haven't checked. Just let me stop the presentation. Yeah, please tell me doubts from week 11.
Ma'am, activity 11.6, question number 2. So, ma'am, in this question,
Okay, you can see here. We can see here from here the sequence of nodes visited in BFS are A,
that
B,
is
C.
my
Wait,
doubt,
wait.
ma'am.
Yeah, we'll see. A followed by BC, then EFD, I think. Then EF, then ABC, followed by
D. Ma'am, if we start from D, then we should go to F and then E. But in the sequence, it jumps from D to E, then goes to F. That is what my doubt was, that why we jump from D to
okay,
directly
okay,
E.
let us understand this. D and then EF and then G, EF, then G, H, I, J, L. I think they mentioned this. G, H, I, J, L, then KM. So actually, level by level, it is happening. Within the level, it is checking like the smallest one according to the alphabetical order, which is the smallest one among B and C. B is smallest, so B is coming first, and then C, and then among this EFD, which is the smallest thing, D, and the next smallest one is E, and then F. That is how the traversal is happening according to this code.
Okay, for each level, we will check the alphabetical order for that.
Yes, yeah.
Okay, got
So
it.
now here also we can see which is the smallest among all the like alphabetical orderly. G, and G,
GHIL.
yeah, I, J, L something, yeah, smallest thing. Coming to K and M, which is the first visited thing, K. That's how it is happening. So level by level, we are checking the smallest one. Okay, what is your doubt? Starting from the node A, which algorithm will visit the least number of nodes before
No, ma'am,
visiting
that
D?
question I got. That question I got.
Mm,
I was just asking about the sequence of it.
mhm, mm. Yeah. Okay, everyone understood how actually in the BFS, yeah, BFS, you, yeah, it is just, I think it is given in activity only, right? Yeah.
Yes, ma'am.
Mm.
Ma'am, actually, in the same question, when we are going with BFS, I am getting a different answer. The only thing which is differing is that after going to ABC, I think we should go for E and F, but in the answer it goes A B C D and then E F. So I'm not getting, if you go to the point
Yeah,
after.
see, if you see the level, the next level, this level, third, like first, if first level is A, second level is BC, and the third level is EFD, no? So if you see among them, which is the smallest, D, followed by E, and followed by F. That's how the traversal is happening. So within the level, we are visiting the smallest one first, and then the second smallest, and then how that's how the traversal happening. So here also you can see the list of alphabets here. So among them, among this the fourth level, which one is the smallest? Among H, I, J,
G,
which
G,
G, and after G,
I, H,
H. Yeah, that's
I,
how.
J,
I,
L,
J, L. Yeah. Then coming to this fifth level, which one is smallest? K and M. That's
L.
how the traversal is happening in BFS.
Okay, ma'am. So the last time when we were doing DFS, so the way we were going back to the earlier stage was tracing the task कि हम कहाँ से आए थे. Now in BFS, how we go back?
So no backtracking is required, no here.
Yeah.
Here no backtracking is required because
Okay.
we are going level by level in BFS. Only for DFS we are visiting like if smallest one first if there is some time. Yeah, if all of them are visited, we will backtrack for DFS. Here backtracking is not there for BFS. Okay.
Ma'am, can we go with the question number 3 of 11.5?
Yeah.
Ma'am, here I'm not able to understand the difference that this time double time unit is making. I think I'm answer wise so I got, but I'm not making sense. Like why double unit is here and what difference is it making?
So what does init of L will give? Initial part of your list.
Yes, the first one.
Yeah. For that, if you apply initial element, so the what it will give? It will give, yeah, it will
Third
remove that.
last.
Yeah. So you are not iterating over the complete list. Actually, what you are doing is you are skipping the elements here in your list while you are iterating. You are not take you are not calculating the complete sum of your list. So what it will be there? Last element will be there. So last of L plus, so you are taking the initial part of your list first. So that will be n minus 1 element. And then for that, again you are taking init of L. So that will be 1 to n minus 2 element you are taking. So let us take 1, 2, 3, 4, 5 as our elements of our list. What it will do? It will happen 5 plus list
Three.
sum of 5 plus list sum of init of L. Init of L will be 1, 2, 3, 4. For that, init of L will be 1, 2, 3. So again, you are taking 1, 2, 3, list 1, 2, 3 only. So for list 1, 2, 3, what you are doing? So previously 5 plus, again you are calling list sum of this procedure, no? So it will be now 3 and 3 plus 5 plus 3 it will happen, and again it will be now list sum of init of L. Init of L will be 1, 2, and from 1 to it will be again 1.
One.
So it will be 1. So yeah, if now finally you will get 5 plus 3 plus 1. That will be your answer. It will be 9. So what it will do? We are taking the sum of which positions?
So ma'am, if n is odd, then it would add all the odd numbers, and if n is even, then it would add all the even numbers.
Yeah.
That's what it is there in the options. So you can choose the two options here. So basically init of L, you are doing to skip the positions. Like here, if you take init again, you are not iterating over the complete list. You are just skipping the elements here. Your last element, you are skipping one element each. In every iteration, you are skipping this middle element. So if your n is even, if it is, let's say if it is 4, then this third element will be skipped. So all even numbers you will be adding. Yeah, if it is odd number, if n is odd number, you will add all odd numbers. Okay.
Okay, ma'am, got it. Ma'am,
So
would you
you
be
can see,
the
yeah,
question 4 of 11.4 as well?
11.4 question 4. So assume that there are 11 nodes in the longest path of DFS tree drawn according to the concept used in the lecture. Okay, answer the following question. The end node, I think I have to see the lecture in order to answer this. Anyone
Yes,
of
ma'am.
you, would you like to answer this question if you remember anything?
Ma'am, in that lecture, professors are using two DFS, two recursive procedures. So one recursive procedure is calling another, and the another one will be calling the first one. So it depends what is your starting node, and then only you can find out what would your end node be. it can be a explore train procedure, or it can be a explore station procedure as well.
Okay.
So if you just go to that slide in the lecture, it would be visible in that.
Yes, like in the lecture, what he was doing, like he took a station. No, he took a train first, and then
Yeah.
managed and traced all the stations that the train is going through. And this way, he was doing double. Like the train was searching for station, and the station was searching for train. This is how
Correct.
it was going. But
Correct.
what I'm not able to understand is here is in the question number 4, it says that longest path is having 11 nodes in that. But how come I'm not able to understand the nodes and the numerology which is going on here in these examples and questions?
So how many train nodes can be visited? No, it is not how many train nodes. What will be the train nodes here then? So you are telling it will be happening like station is searching for
Station,
train.
train, station, train, like that.
Yeah, that like that. You are starting from station. So station and then train, station and then train. You will get station. You have to write that 11. Like you have to write it like S T S T S T S T S T. So on, like you will totally there should be 11 things, 11 nodes. So if you start from station, then how many train nodes you will receive?
Yeah,
You can
mom, I've
count.
got it now. It's 5. Thank you.
Yeah, yeah.
Yeah. It's like their nodes will include stations as well as the train, not only the station. Okay. So that is how if there were 11 and it was starting with station, then 5 will be train.
Yeah.
Okay.
So any other doubts from 11th week? Any other doubts you have from 11th week?
No, clear.
Okay.
Ma'am, actually, when I saw my dashboard, there are two things coming up. Like in our earlier quizzes, the quiz would start at 2 and it will get over at 6. But there is FN and AN session. That means the first 2 exam will be in the morning session, the next 2 exam will be in the evening session. Is that so?
Yeah.
Okay. So is there going to be any difference in the pattern as well of the exam, or is it going to be just the same as where the quizzes were going on?
The same as quizzes, but you will get some extra time now for midterm. That's all. Yeah, pattern will be same. The questions, everything, whatever you are seeing in quizzes, the same pattern, the same difficulty level, and yeah, it will be in that manner only.
Ma'am, are we done with the quiz solution of the quiz 2 and the quiz 1? Like quiz 1 ka to ho gaya tha, I'll search for that. But if the quiz 2 solution has been done,
Yeah, mostly yes, I think. Anyone of you have you attended quiz 2 solutions session?
No, ma'am.
or if it is done, like where can I find it?
I don't think there was a quiz to solution session or something,
Yeah.
discussion session.
Yes.
Yeah, I think mostly it is there, I think, because previously people were also telling some of the quiz 2 questions are discussed when in some other sessions, but I'm not sure. Can you ask this in Discourse or something? Yeah, if you have any doubts in the quiz 2, we can discuss that also.
Okay, ma'am. And another thing is like, can you just tell us how do we prepare for the quiz, like the end term exam? In comparison to quiz 1 and quiz 2, it's absolutely important for us to be focused about that. But I'm not getting like how do we go about it? How do we prepare? Because I've not even taken any book also. What I'm doing is just following the lecture and doing the exercise. But now, can you please guide us the way?
Yeah, please go through week 12 concept summary slides that are there, which will help in revision of this concepts, and then try to solve all the weeks practice graded assignment questions every weeks. So yeah, first make conceptually clear like every week topics, and then go to solve then solve all practice and graded assignment questions by yourself, and then revise your quiz questions also, some mock questions also, everything more practice. See, the thing is like it is simple only, but even if you make little logical mistake, then your answer you will get some incorrect answer in CP. Yeah.
Ma'am, in the earlier week, I saw that there was a document that used to be uploaded about summary of the whole session. Karke. But for the later weeks, I didn't see anything like that. If it can be provided.
Yeah, I think only for income, like for initial weeks it was there, but later weeks it was not there. I will check if it is there, then we will ask them to upload.
Yes,
Yeah,
ma'am,
but
please.
week 12 slides are very good. If you go and watch week 12 summary slides, they are very good.
Yeah, ma'am, but the kind of document that was uploaded in the summary was very nice.
Okay. Yeah, we'll see. I think only for the initial weeks there is this documentation.
Yeah, it was, I think, only for the first 4 weeks.
4 weeks, yeah, because for qualified students it was there, yeah, to help them. Okay, any other?
Yeah, mama. Another thing is like, ma'am, actually, I have to change my email ID. Earlier in the doubt session, I asked her, so she said that we'll get our official email IDs and the portal will be changed a little. But till now, nothing has happened. I just want to know, like, is it with me only or everyone is using the same thing?
Yeah, can anyone confirm? Actually, after qualifier you will get some official mail ID, right?
Yeah, ma'am, it has been almost 2 months, but nothing has been given to us yet. And for some research and college research, and I need an institution ID to go through with that. So I think that will help me a lot.
Yeah, can you just write to operational team? So any others have you received after qualifier? Have you received official mail ID?
Ma'am, after qualifier, IIT don't give us the student mail ID. I'm a term student when September 2022 batch. After qualifier, you have to actually pass one term. And after that term, before the next term starts, you get the official email ID before 15 days of the term starts, and everything, the discourse access, you get everything. After one term you have passed. Before that, you have to just go through that the registered email ID that you actually used to register for this course.
Okay. Thank you so much, sir. Another thing, like I was considering, like there are so many societies and everything. So I think it will all be allotted after term one, right?
Yes, absolutely.
All right. Thank you so much.
Hello.
Yeah, yes.
Hello, ma'am. I have a doubt in graded assignment 6, question number 4. Can you please look into it?
Which
Graded
one?
assignment 6, week 6, question number 4. Uh, yes, ma'am.
Okay.
Ma'am, the doubt is that I had actually raised this question in earlier session as well. My doubt was that the answer that is being shown is that we have to select that error is in line 2, 7, and 16. But I had selected that errors are in line 2, 6, 7, and 19. But when we check it, if we like when we go through the question, if we see rather than correcting line number 16, if we make changes in 6 and 19 respectively, we'll get the same answer. Like uh, that will be also like correct. If rather than just correcting like 16, if we go with 6 and 9, like 16 is saying that present should be true. If we go with 19, like if we make correction in 19 and in 6, like in 6 we remove the not and in 19 we make it false, I think the answer will be same. Like rather than making in one, we are just making in two statements.
So you should, if you could please check through it and like tell it if, because I raised it in earlier session and the teacher was like, you should like, we'll discuss it and like you should raise it, and he was also kind of confused. So if you could like
Can you
look into
repeat your
it.
question?
My question is that if rather than making change in line number 16, we make changes in 6 and 19. So
So
the
yeah, so what you're telling, if not member of x comma s comma this x dot customer name, then you will say s equal to s plus plus
if
x. Mm.
okay, when we go through the question says that it accepts a shop name and parameter, and additionally each customer must be represented exactly, and we have to like present the list of names of people who have visited a particular shop. Okay, so if we just remove in 6 we remove the not, if in 6 we remove the not, and in line number 19 we convert it into false.
See here,
Yeah.
if it is not a member, then only we are adding that to the shop name, right? We
Okay.
are adding the
Okay.
shop.
Hmm.
Yeah, but if it is a member, then what you should do here, if it is already a member, that if
Ma'am,
this,
yeah, we have to like go through the whole like program. Like when we'll see the member
what
procedure
is the
member.
question? Just
Yeah,
let
yeah,
me
yeah,
see.
yeah.
The
Okay, okay.
procedure visited shop returns a list of names of people who have visited a particular shop in the shopping bills dataset. Who have visited a particular shop in the shopping bill. It accepts shop names as parameter. Additionally, each customer must be represented once in the returned list. The following pseudocode may have mistake. So it is actually taking some shop name,
Yes.
shop's name as parameter, and s is initially none, and while x dot, okay, that particular shop name equal to that particular shop name. So
Shop
what
is
it
there.
is, yeah, if it accepts the shop name as parameter, here list of names of people, names list of names of people who have visited a particular shop. So that's
Oh
why we
yeah.
are checking that particular shop, and
Yeah,
whatever the
if the
shop
shop
that is.
name is, if x dot shop name is equal to shop, and if the person's name is like, if
Not in the
not,
list. If it is
yeah,
not in the list, then only we should add that particular.
But ma'am, if we change that condition, if we remove
yeah,
that not, that will never work
not.
because that will never work because the S is
Yeah, that
already
won't.
empty.
Yeah,
No,
that
no,
will.
I'm telling we'll replace the not, but in the member procedure member, in the line number 19, we make present is equals to false
Why you should do that?
to make it work. Like it can work that because we have to find the error
No,
in this program,
why?
na?
So for each x in L, if x dot equal to name, then present equal to false.
Ma'am, when in the like whole it will be like because in like in line number 16 we are making it false, like it is saying that error is in line 16. By making it false it will work in 16, but what I'm saying is rather than doing that we can do that in line number 6 we remove the not, and in 19 we make it false. So can you please check it in that in both the formats if it's possible? Like in there is also error in line number 2 and 7. So if you can like just go through it in that way and like tell me, I think that according to me, I think the
See,
way I am
if
doing, yeah.
so, when you are exiting loop, after saying false, you are exiting loop. When false is happening in your case, so you are initializing present equal to true only, right? You are telling present equal to true, and if so return present, you will return the, if it is returning false, you are returning, if it is returning false, then if not a not member of s comma, if not a member you won't check. If member of s comma this customer name you are telling, you will check. So if member that procedure, if it is returning false, then you are telling, then you will append this shop name that you are telling, no? That's what are you telling?
Ma'am, your voice was a kind bit. Ek minute, just let me go through it and then I'll tell what, because I got also confused while you were speaking. Okay, just I was saying that Ma'am, can you give just 2 minutes? I'll just go through it and I'll clarify more because I got confused in this. Okay, just 2 minutes.
So actually that doesn't make sense also. Member function will check whether that particular element is present in the list. If it is present, it should return true. That's what you have been taught also. You cannot do that also actually, technically. Yeah, what member function, whatever that is taught, it will check for an element in the list and it should return true if that particular element is present in your list. If that is not there in the list, it should return false. That should be done.
Hello, ma'am.
Yeah, yes.
Yeah, ma'am. Now the thing is, when in 16 we are making it present is equals to false. Okay.
Mm.
Suppose we are making present is equals to false in line number 16, which was original answer. Okay.
Mm.
So when we'll make it false, so what will happen? We'll make the list first in the first procedure. When we go to first procedure visited shop. So we are checking if the x dot shop name is equals to shop. Suppose if it's true, like the person is visiting to that shop, then we'll go to line number 6, which will check if not member s comma x. So member, what is member doing? It is taking the list s and it is taking the name of the customer. So in line number 16, if we make present is equals to false. So suppose if the name is present, like if the name is, we are going to if block, if x is double equals to name, that is if name is already existing in the list, then it will make present is equals to true. Now we are only talking that line number 16 is false. So if name is already present in the list, that is if x double equals to name, then present will become true.
Yes.
And then in line number 6, if not member, that is because it is already present, so member will return true. And if not of member, yani if not of true, that is if false, then it will not add. But if it is not present, that is X is double equals to name is not, there is no name existing like that. So line number 16, that is present is equals to false will be returned. And if not of false, yani if true, then it will add the name. So this is the, when we convert line number 16, this is the conclusion we are getting. Is it fine, ma'am? Clear?
Yeah, yeah.
But now what I am saying is, we replace 19 with present is equals to false and 6 with if member f comma x
Tell me
customer
what
name.
your member function is doing. What your
Member function is checking if the name is present, it is returning like if the member is present, then it is returning a true or false value, and if the member is not present, then,
No.
and we have to
It
rectify
what
that error.
according to you, if the
Yeah.
if that particular element is present in the list, it is returning false. That should not be done. If the particular member is present, if the particular element is present in the list, it should return true. Whatever
But
according
ma'am,
to the explanation given in the lecture
the
also.
thing is, no, the thing is, the question just simply says there are some errors which because of which the program is not working, and we have to rectify those errors. So by my procedure, the answer is correct, because by my procedure, the answer is coming. It doesn't say anywhere that this should be a particular condition that only true shall be returned, and when we
it is mentioned many times, like member function checks the particular element is present in the list. If it is present, it will return true. That's what it is being taught.
But
It's
ma'am,
key.
if it is
Same thing for
we are not, no,
key
no, ma'am.
procedure also. The same thing
thing
for
is,
key procedure also. It will check whether the key is present. If it is present, it will return true. That's what it is taught in the lectures. That's what we
I'm
are
not
expecting you also to learn. Okay.
Yeah, I understand. But ma'am, I'm not saying that it should not return true. I'm saying that it returns false but checks for true. Line number 6 will check for the truth value only.
Your member function, if that particular name is matching, it is returning false. You please check. If
Okay,
X equal to equal.
it is. So that's what I'm saying. If it is written, the logic
That
by
is
me
not.
is
Yeah, please don't argue. There is nothing to
ma'am,
argue
I'm not
here.
arguing. Not arguing. I'm just presenting one thing, that you are saying that the logic says that if the name is present, then it should not be added. It isn't saying that if the name is present, then we should add
No,
it.
the thing is
that
about the member function. What it is taught in the lecture? Member function, it will
yes, ma'am.
return true. That is being expected from you also, not this kind of logics. Okay. Other
But ma'am,
logics.
just one point I had to like, if you could allow, I'm not arguing. I respect your opinions and everyone's, and just that's why I'm just raising one thing, that in lectures we were taught that what it should return true according to the condition. The condition here says that if the name is already existing in the list, then it should not be added. That is, if the name is already existing in the list, then it should return false, because it is said that if the name is already existent, then it should not be added. It should be added only once. And that's what I'm checking, that is if X is double equals to name, that is if the name is already existent in the list, present is equals to false, then it should return false. And as you are saying that we should like return true for the subject, then by that my approach will be
just listen.
definitely.
Yeah, member function. What is the functionality in the many questions also? You can see member function does this. It is mentioned clearly. It returns true if the particular element is present in the list. If it is not present, it returns false. That's what you have to implement in the code also while writing member function.
But ma'am, it is returning.
Yeah, please. There is nothing to argue here. Yeah, it is like not correct also. What like whatever your explanation is giving, that is not according to what is being taught related to the member function. Okay.
Ma'am, just another thing, the function will return true. Like if I am saying that like if there is a distinct
when it
name,
will return true,
then
member
it will
function,
return
it
true.
will return true when there is no element,
no
when there is
repetition. No, when there is no repetition. Like suppose I have bought from the same shop 3 times, so it will return false. But if you have bought the same from the same shop only
I'm
once,
talking
then it is
about the member function.
distinct.
When the member function will return true according to your case, it will return true if that particular element is not there in the list. That is not being expected.
No,
okay.
Yeah,
That
ma'am, I
is
understand that.
yeah, that
But
is what
ma'am,
your member
yeah,
function does that.
the thing is, ma'am, my member function will not return false in absence. Like it will return true when it is for the first time. Like if it is like for the first time, like mine, if I have
No,
bought
member
3 times.
function will return true according to your logic if that particular element is not present in your list.
No, yes, ma'am. Ma'am, please, like if you could please like go through it, because it will return true when it is
Ma'am,
for the like
this logic
for
will
the
work.
This
I think it's
logic will
logic would.
work. Yeah,
no,
it
ma'am.
will work, but it is not being expected by you
Yeah,
to
yeah.
do that.
That
No,
Yeah,
ma'am.
that part I got, ma'am.
No,
yeah.
ma'am. The thing is, like you are saying that my will return true when there is absent. It will not return true when it is absent. It will only
No,
return
no,
true
your
when it
logic
is
is
for the
fine. Your
first
logic
time.
is fine. Your logic is fine. It's
Uh,
same in
uh,
the procedure
yeah,
member.
ma'am. So,
See,
and
member
if
function, you are initializing it to true only. So let us take one
yeah,
element in the list which is not there.
yeah.
Yeah, check
Okay,
what
okay.
we will
Suppose,
have.
okay, ma'am. Suppose we are taking a list where, suppose my name is there. Suppose my name, suppose it is X. It is already present. Okay, so now what will happen is it will go through the first. It will go through Y. Suppose a new name Y comes. Okay, so it will go through list. List has L has X already. My name is there X, and now a new name Y has come. So present is equals to true. For each X in L, that is for each X, for each element in L, it will check if Y has already occurred or not. But it will see that Y has not occurred. So present's value will be true and it will return value as true. Now
No,
in
your
the
present value will be false. You are telling
no,
according to
no, no,
line.
but no, but it is not present in the list. Now for each X and L, X
See,
list L,
whatever logic you told, line number
yeah,
19 has to be corrected. Line 19 present has to be
yeah,
false. You
yeah,
have
hmm,
mentioned. So
yeah.
according to this logic, your member function will return true only if the element is not there in the list.
No,
It will.
ma'am, the thing that's what I'm explaining. It will not return.
Let
It
me
will,
explain
yeah.
you. You are not explaining properly. Let me explain you.
Okay.
Okay.
Mm-hmm.
Let us take the Chennai. Okay,
Okay.
Chennai element is not there in your list. Let us take Chennai. That is not there. That is your name. Name is Chennai, and your list
Okay.
is, let us like in the list Chennai is not there. Okay,
Okay.
then what
Hmm.
it will be? Present
Okay. Yeah,
equal to
ma'am.
true. For
Yeah.
each X in L, there is
Yeah.
nothing. No use here. No
But it is
iteration.
return. Yeah, ma'am. But it is returning present, so it will return true value. If my name is not there, it will
Not there.
return present.
It is not
So,
there. Chennai is not there. It
ma'am,
is
ma'am.
returning true.
No, no. The thing is, suppose if list has Madurai, if L has Madurai, and
Then
I am
what it will
entering
return?
Chennai, it will return present is equals to true. But
Ma'am,
the
just a suggestion.
logic,
Uh,
yeah.
this will go on for too long. We can take a dummy data and we can actually try out his code. If it
His
works, then
code,
it works.
yeah, it code works, but the member function, what we are telling,
Yeah,
member function should return true if that particular
correct, ma'am.
element is there.
We all
So,
got that point, ma'am. We all
yeah,
got that point.
if the particular element is not there, it should return false. According to his logic, do you agree? Like whether then so if the particular element is not there, then this element, this method, this member function will return
Actually, ma'am,
true.
what he's doing is he's not actually trying out the member function. He's actually creating a new function that, although the name is same, but the function of it differs in the code. The result would be the same,
No,
but the
let
functionality is
see
different.
The
basically
functionality,
member
yeah.
function, whatever that is, what we have seen, that what it does, it accepts a list, some element of the list,
Mm-hmm.
and
Correct.
it will return true. That's what being expected also member function to
Ma'am,
do. Yeah,
suppose if
if
we change line number 16 to present is equals to false, then also the logic will somehow differ, because then it will be, suppose if there is a name occurring for first time and then also it will occur false. So in a way,
no, you
in
are
both
not
the cases, if
understanding what member function should do.
I understood, ma'am, what you are telling, that it should return true when it is that. But according to the question, it is demanding that if the name has occurred twice,
See what
it
member
should not
function
occur
does,
again.
according to you, what member function should do. Please tell, according to you,
Ma'am,
what member
according to member function, it should relate to what the main function, the calling function is telling it, and it should
No,
help
what
it,
is being
assist it
taught
in
in the
that way.
lecture? Please tell what member function should do. Please
Yeah,
tell.
it was taught that it should like it should return like it should return a positive value when the condition, according to the condition required. Like if the
No, you are
condition
not telling
is
the approximate, like exact thing also. So actually, to the member function, you are passing a list and some element. So what member function should check is whether this particular element, whatever we are passing, that is there in this particular list or not. We should check. If it is present, it should return true. If it is not present, you should return false. But what you are telling is something present once, present twice. That is not the thing we are checking. Here we should check whether that particular element is present in the list. If it is present, then it should return true. If it is not present, then it should return false. Okay.
So, ma'am, the thing is that logic is correct, but the usage is wrong because the member
Yes.
is okay. So, but ma'am, how will we differ? Because the question didn't say any. It just said that wherever the mistakes are, you should rectify those mistakes so that the
Yeah,
code works. And like,
that's what. Yeah, member
because
function,
ma'am,
that is being
I
taught. That's
understand.
why there is no point of argument also. That is being taught
No,
explicitly.
yeah, ma'am.
Member function should do that.
I'm sorry. Yeah, I'm sorry if you felt like I wasn't arguing. I was just like putting facts. If you felt like that. So, but I just wanted to say that when such a
Yeah,
question
that
occurs,
code
because I
works.
in
That
my
code works. But
yeah,
what
yeah.
is being taught, that should be kept in mind. Okay, that
Okay.
code works.
So
Yeah.
if such a condition occurs, we have to like understand, because in my notebook when I was actually doing for grade, I actually had both options, line number 16 and 6 and 9, but I like passively chose 6 and 9 and 6 and 19 and left 16 because I thought that anyone would work. But then I got to know
See,
that
even if you
so
say this
yeah.
code completely can be written in some other way by some other people. But the thing is, what is taught, that should be kept in mind,
Okay,
member.
yeah, I
Yeah,
see, I
someone
see.
can write it in some the way, initial of initial. Yeah.
Yeah,
That can
means
be
a
done
code can be done in n number of
any
ways, but
any
as a
number of ways.
learner, as
Yeah.
a learner, we should like focus on basics and
Yeah,
those
as
things
a
should be
learner,
like
we should keep
okay,
like
yeah.
what. Yeah.
So whenever this kind of question occurs, we have to like go with the answer that is like with the like member should return true, like whatever condition is there, it should be
So
true.
the
Okay.
same thing for is key also. If something is written is
Mm-hmm.
key, then
Mm-hmm.
is key procedure returns true if that particular key is present in your dictionary. Yeah, that is
Mm-hmm.
what we will think also to you to
Whenever.
what implement. Okay, but if you
Mm-hmm.
try some other logic, then it will also work. But yeah,
Mm-hmm.
but the point is like you should be in line with what is being taught.
Yeah.
Okay.
The
Yeah.
main confusing thing was that
Yeah,
both the
that
thing were
see,
present.
yeah.
The option number 6 and 19 both were given. So I was kind of confused that why have they given 6 and 19? I thought that they were kind of challenging us, or I got into that. I saw 16 and I clicked it, but then I saw they have given 6 and 19 both as well. So I thought they might be like expecting us to go deeper and deeper and all that. But okay. So in future, whenever this kind of question occurs in quiz, both the options will not be present, right? Like such kind of question will rarely occur, or there are chances that we have to make such critical analysis.
No critical analysis. You just stick
Like
to whatever
yeah.
being taught in the lecture. That's all.
Mm-hmm.
Don't go like critically. You don't
Very
need to
deep.
think.
Yeah,
Yeah.
I actually went like it might be expected from us to go with more options and all that. So I kind of went that. Okay, got it. Yeah, this was a question that had been like stuck very much, and I tried to raise it in discussion, and there was some explanation, but they only said that you are choosing two statement over one, so that is wrong. So I thought that is a very vague explanation, and so I thought to raise it. So
See,
yeah, thanks a
see
lot.
the
And
thing. Yeah, the
yeah.
thing is, so even whatever we are doing here, that can be done
Mm-hmm.
in different ways. But the thing
Mm-hmm.
is, you are being taught the most efficient way of doing, not
Efficient way,
efficient,
definitely.
not that is
Like
practically
most
what.
most basic suitable way that we have to always keep
Yeah,
in
that is
mind.
true.
Yeah.
So in the while the condition also, so yeah, that the thing is like you can for the if condition also, not you can keep not, and
Mm-hmm.
yeah, the thing you can do. But the thing is the
Definitely.
most efficient, and it is like what
Mm,
sin
See,
what
as a
we say,
beginner, like the
yeah,
most
best
prom best
Yep.
way as a beginner to understand. And
Yeah, best
yes,
way
I
to
feel,
understand the programming or something.
yeah,
That
yeah,
logics has been taught, so you have to be like, yeah, that has to,
more
that
concerned and more, yeah, definitely. I got your point, yeah. And yeah, okay, that has been. And sorry if you felt like I was arguing, because I got a bit excited, because this had been very, very long in my mind, so I couldn't like raise it.
yeah,
So I
okay,
finally,
okay, I
yeah,
understand.
okay, thanks a lot, because
Yeah.
I was seeking this explanation for a long time, that why it was marked wrong. Okay,
Okay.
so yeah, thanks a lot.
Yeah, but don't just stick to the
Le-
basics only. Yeah, don't
Definitely,
overthink. Yeah.
definitely. I got the approach now, how to like proceed with these questions.
Yeah.
And
Okay, that
another thing,
yeah.
in week 12, will we have any assignment, or
No,
is it
no.
just a tutor?
It's a
Oh,
revision week. No assignments will be there on week 12. Yeah.
okay, okay, okay. Yeah, thanks.
Yeah. Okay. Yeah. So any other doubts? Yeah. Or shall we close?
No doubts, ma'am.
Yeah. Okay. Then I think we can end this session. Thanks all for joining the session.
Thank you, ma'am.
Thank you,
And
ma'am.
have a good night, ma'am.
Thanks.
Hello. Hello, sir.